welcome all to my YouTube channel Mechanical Study, where we study different mechanical system. In today's lecture we are going to study about vapor compression refrigeration system. Vapor compression refrigeration system is basically used in refrigerator and air conditioner for the purpose of to achieve refrigeration effect. So vapor compression refrigeration system basically consists of four parts: evaporator, compressor, condenser and expansion device. So we will study one by one. So first of all we will see a working of a evaporator. So basically evaporator consists of a so in the evaporator a refrigerant will be flowing. So refrigerant, it may be R12, R134A, R R22. So there are different types of refrigerant that may be used in a vapor compression refrigeration system depending upon the application where it is used. Now in the evaporator, as the liquid refrigerant or a liquid plus vapor refrigerant will be entering. This is the refrigerant that is leaving the expansion wall and entering the evaporator. So it will extract the heat from the surrounding space and rise its temperature and converts itself into a vapor refrigerant, and then this vapor refrigerant will be supplied to the compressor. Now basically in a evaporator, a evaporation process will be carried out, and this process can be shown on pH diagram. Here we can see a pH diagram on your screen. This process 421 indicates about the pH diagram, where the liquid or a liquid plus vapor refrigerant, this 4 indicates a state of a wet refrigerant which will be converted into a either saturated or a superheated refrigerant depend upon the degree of superheat. Now I am considering the simple VCRS cycle. So point 1 will be indicated on the saturated vapor line. Now we will first of all see a curve. This curve indicates about the saturation curve. This is called a saturation curve. A region leftwards to the saturation curve is called a subcooled liquid region. A region rightwards to the curve is called a superheated vapor region. Now a region in between this is called as wet region, where the state of the refrigerant will be in the combination of liquid plus vapor. The uppermost point of the this curve is called as critical point for that particular refrigerant. Then so this is the curve where we can plot vapor compression refrigeration system and the various process that is carried out in the vapor compression refrigeration system. Now in a evaporator, the process that is carried out at a constant pressure. So this will line, that is line 421, will be a straight horizontal line. Okay, so there will be a heat addition process that is carried out from in the evaporator, where the will get the one horizontal line, that is a constant pressure line. Now once a state 1 is achieved, that is the state of that is a refrigerant which is at a saturated vapor state, then this refrigerant will be supplied to the compressor, and this in the compressor the refrigerant will be compressed, and compressed refrigerant will be supplied to the condenser. Now once the refrigerant is compressed, this indicated by a process 1 to 2. Here a pressure rise will take place from P1 to P2, and this is the basic working principle of a compressor. Means so compressor is generally used to compress the refrigerant and rise its pressure and temperature and supply it to the condenser. Now once it enters into the condenser, in condenser the superheated refrigerant that is at a state 2 will get condensed into a saturated liquid at point 3. This process 2 to 3 is called as condensation process. This is also carried out at constant pressure. Now during process 2 to 3, what happens, as the liquid refrigerant enters the condenser, a cooling medium will be used in the surrounding to the condenser in order to cool the refrigerant that is flowing through the condenser. Now the cooling medium that is used for the purpose of cooling of a refrigerant, it may be water or it may be air. So it will be depend upon the refrigeration effect that we have to achieve. Now if, if the load on the evaporator is less, then we might use air as a cooling medium on condenser side, and if load on the evaporator is more, then we can use water as a cooling medium on the condenser side. As we all know that in household refrigerator we generally use a condenser which will be used or which will be cooled with the help of a surrounding air that is present in the kitchen or surrounding to the surrounding to the condenser. Now in case of a ice plant or a cold storages, we have to use a water for the cooling purposes, as the load on the evaporator is much more higher than in comparison with the household refrigerator. Now once this refrigerator enters into the expansion hall, as it will flow from process 2 to 3, a condensation process will take place where the superheated refrigerant will get converted into a saturated liquid. Now in condenser there might be a case of a subcooling of a refrigerant. If subcooling takes place, then this horizontal line will extended up to a subcooled region and we will get a point 3 dash where we will get the subcooled liquid. But I am considering this is a case where I will get the refrigerant, that is at the outlet of a condenser I will get a saturated liquid refrigerant. So if I get a subcooled liquid refrigerant at the outlet of a condenser, so this process will be like 3 dash 4 dash. Okay, and this will further increases the refrigeration effect on the evaporator side. So this is the main working basic advantage of a subcooling in case of a condensation process. Now once this refrigerant enters the expansion device, the expansion process will carried out. During expansion process, what happens, as the refrigerant enters the expansion wall, a expansion process will be carried out. Now expansion process that is carried out at constant enthalpy, means it is also called as an isenthalpic process, where enthalpy of a refrigerant will remain constant but the state of a refrigerant will get changes. That is, during expansion process pressure of a refrigerant will get decreases, and here we can say by process 3 to 4, as air pressure decreases, so some of the liquid refrigerant will get evaporated and converted into a vapor as shown by the process 4. So some of the refrigerant will get evaporated and converted into vapor. So at the point 4 I will getting a combination or mixture of a liquid plus vapor, and at the point 3 I am only having a mixture, only having a condition of a saturated liquid. Now at point 4, that is the at the outlet of a expansion wall, the condition of a refrigerant will be liquid plus vapor. Now this liquid plus vapor will be supplied to the evaporator for the purpose of refrigeration effect. Now this refrigeration effect can be shown by process 4 to 1. So this is all about vapor compression refrigeration system that is generally used in a refrigerator or air conditioner, and the process is also called as a refrigeration. So do like and subscribe to my channel. Thank you.